Apparently you want to be very careful with the coating on the dish because it's hydrophobic. So I'm going to cover mine with newspaper just so it doesn't get marred up or scratched up while we're cutting into this guy. Although there is already a defect in the coating on the dish, so I'm not really sure what that's about, but oh well. Okay, so this is definitely not the best way of doing this. I'm just kind of working with what I have here, but I'm using a square bit on the router, and then this is 1 inch off the deck. And I got 1 inch as sort of like a safe measurement. You can cut higher, but if you cut higher, you cut further in on the dish, and then you won't separate the motor mount cleanly from the dish, and then you also run the risk of nicking the Ethernet cable, which is on one of these sides in here. Ooh. All right, we did it. So yeah, this right here is what makes it really difficult to cut this thing open, or at least a little bit nerve-wracking, is you don't want to go so low that you hit this component. But there's also an Ethernet cable plugged in right here, so you don't want to go too far in. Something that's worth noting is that you can see there's like standoffs on the inside of the dish. This supports the circuit board, and I'm not going to replace those in any way, but you are modifying this, and it is possible that it won't last as long. I feel like this is to protect the board if like a coconut were to hit the dish or something, but I don't know, it might sag over time and not work as well or break. Alright, sorry we went blurry there for a minute. You can see these are the tilt motors, and then this is the cable that we are interested in. I'm just going to start feeding this out. So I think now what we need to do is remove this plastic cap. It's sort of like the locking mechanism thing. Okay, so what I'm trying here is I've got a little tension on this button here, and then I'm just going to try to push this in, thinking that will allow this whole plastic piece to slide out. Okay, so yeah, we can see we got a little pop there, and now this is just coming right out. And right here is the other end of the cable that we're trying to harvest. So I believe this will just unclip. And now we're just gonna pull this through. Okay, so we're done with this guy now. All right, so now that we have this cable out, we can test the dish and make sure it is still functioning. So what we're gonna do is we are just going to carefully plug this guy back in. Okay, for some reason it's having me configure the network again. I don't know why. I already set this up. The hardware hasn't changed. So yeah, it says I'm online and downloading an update. So yeah, I really don't know what's going on here. Okay, so I don't know what's going on with this router. We're not going to use this router anyways, but yeah, right now it's unsecured. But as you can see, we are on YouTube no issue. So it seems like the performance is just fine. We are able to stream video Seek. Man, this is like faster than my Wi-Fi at home. I don't know. Okay, yeah, we've got a little low quality. Or no, this is just a shot that I put in that was blurry. Yeah, this is working really well. Okay, so now we're going to work on the DC conversion. There's a lot of different ways you can do this. You can even modify the stock Starlink router to run on DC and bypass the power supply. But I'm just going to use this little travel router. This should be plenty fast enough, and it's really compact, which is nice because I'm working with a pretty tight space here, so this is going to save me a lot of space. And then we've got this little PoE injector. Got this on Amazon. Feels pretty cheap, but I'm hoping it works. Then we have a 48 volt DC power supply, so this will convert anything between, I think it's like 8 and 30 volts to 48, which is cool. So it's a little step-up converter. And then I have one of the cheapest crimp connectors you can buy, and then shielded RJ45 cable connectors. It's important to get shielded, apparently. I actually don't know how important it is, but that's what I read. What's nice about this router, particularly for my application, is that it's powered by USB-C, so I can use a 12-volt USB-C adapter that I already have. You could use a car charger too. It does need to be 3 amps, I believe. This comes with a pretty sizable power brick, so you can't use any USB-C charger, but I have one that will definitely work for this. Okay, so now I'm going to cut the Ethernet cable. This is the cable that goes to the Dishy, but I'm going to repurpose it and actually use a segment of it to make an Ethernet cable. I'm going to leave a little bit on the router side in case I want to patch into this router and use it again, but I'm just going to cut it there. And then I'm just going to stow this away. I might never use it, but maybe someday. And then I'm just going to cut a relatively short length for this. This is going to go from my router to my PoE injector. So we're putting an RJ45 connector on the long network cable that comes from the Dishy, and then we're making a short patch cable. The reason we have to make these cables is because Starlink uses non-standard wiring order. So the 2 connectors that plug into the PoE injector have to be swapped to this non-standard order. Okay, so this is more or less the moment of truth. If this works, then I'll just have to figure out a mechanical mounting solution. Just have my benchtop power supply. We're gonna measure how much current this draws on startup and use. And then I've got my router. I'm powering it with a laptop DC to DC charger. This is way overkill, but this was just sitting in a box, so I'm going to use it. And then from our router, we're going to our PoE injector. This goes to Dishy outside, and then this is a 48 volt power supply. It's worth noting that 48 volts is enough to kill you. And more or less, I want to be able to flip a switch and turn on my Starlink, so this will simulate that procedure. That means that the PoE injector and the router are going to come online at the same time. Okay, so we don't have success yet. Something's going on with the Starlink dish. It is pulling 5 amps. I noticed this router on its own doesn't pull more than 1 amp. So the dish appears to be using power, the PoE, but for some reason it's not coming through on my Wi-Fi. So I thought this wasn't working at first, and then I was Googling how to fix it, and I noticed I was on my Starlink Wi-Fi. So I was using the internet, trying to figure out how to fix the internet. But yeah, we're just going to do a quick speed test here, and yeah, that's about what I've been getting. All right, I've had this running for about an hour now. Everything seems to be stable and working fine. I did a bit of a ping test, and there was one little lag spike where we got 600 milliseconds of lag, so not the best for like competitive gaming, but been using this. It feels like regular internet. So this definitely isn't the cleanest setup. The wire strain actually isn't bad, or well, it's not as bad as it looks. Yeah, I think this is gonna work. Maybe I'll redo this at some point, but we all kind of know that's a lie. Okay, the next thing we're gonna do is clean up this cable a little bit. I think this has a magnet in it, and it probably won't affect the receiver or the antenna at all, but I want to cut it off, and I want to remove these too, just so it's a little bit cleaner. All right, so this is a 3/8 inch thick sheet of polycarbonate. Depending on how you mount your dish, you may want to go with thicker or thinner plastic for the backing. And basically, I ordered this pre-cut, and the Dishy is just gonna sit in the middle. I'm just gonna have screws coming through the bottom, mounting to this 80/20, and I'll have brackets so that this frame is very rigid. I'm gonna drill holes in all 4 corners so that water doesn't pool in here between the rails and the dish. And then I'm gonna have to drill a hole for the Ethernet cable as well. Okay, this is looking pretty good. I think this is gonna work. The flat edge is sitting pretty flush against the polycarb. It's not perfect. I think my jig that I was holding the router with was wobbling a little bit, but the good news is we're using a sealant that is meant to fill gaps as well. So this is 3M 5200. I'm using the fast cure variant. The slow cure takes a week, but it does create a slightly better bond, and it will apparently bond to polyethylene, which is pretty impressive. So I've seen a lot of people just seal up their Dishy like this and then put some desiccant packets in there and hope for the best. But I think that might not be the best idea. I can see 2 possible problems with this. One is, like, we're at 6,000 feet up here, right? So the air is thinner. If I go drive down to sea level, this whole enclosure is going to be under vacuum if it's not leaking, right? And so that's going to put a lot of strain on the PCB. And like I mentioned earlier, there are standoff points on here in the factory housing. So you're going to be bowing this PCB, and with atmospheric changes, when the sun hits the dish in the morning, you're going to be flexing this PCB back and forth. So it might hold up for a while, but I think long term that's going to be a bad solution. And then the other thing is you're going to be stressing your seal if you totally enclose this. It's always going to be under some form of pressure. And the worst case scenario is that you have a vacuum here, and then, like in my case, it would be very easy for water to be sitting along this edge. And even a pinhole leak will draw water into the enclosure over time. And so I'm going to run a breather hose. This is a 10-foot fuel line. It's apparently treated with UV inhibitors and stuff, so it should hold up pretty good. And I'm running my Ethernet wire into a grommet in the side of my van that used to be used for a TV antenna back when my van was used as a passenger van. So I'm just going to run this along with it and have a breather inside of my van. So that way the pressure will always be equalized with atmospheric. I won't be stressing the PCB as much, and I will hopefully get less moisture in here. So I'm not even going to bother with desiccant packs. I think this is a pretty great solution. Got to give credit to my dad for that one, because I was stressing about how to vent this enclosure without letting water in. Okay, I'm just gonna sand over this line that I drew with some 220 grit. I don't think we need to do a whole lot here. I'm just scuffing this up a little bit. Okay, so unfortunately I had to cut the connector off the end of my Ethernet cable, but that's okay. We'll just crimp a new one on, and we're gonna feed this all the way through the hole. So I have these little wire ties. I've got some 3M tape on the back, and I'm just gonna use that to manage the cable inside my little enclosure a little more easily. A lot of people will cut this cable here and then put on like another Ethernet connector or do some sort of waterproof disconnect. I'm just gonna hide this inside the enclosure though. Hey, so this is Future Max, and I just zip tied the Ethernet cable to the roof of my van and fed it through a grommet here. And I was thinking, wow, it would really suck if I damaged this cable, because then I would have to take apart that enclosure that I just glued together. So that's the obvious benefit, is that you can replace your cable if it gets damaged, since it's going to live on the roof of your vehicle and be out in the elements and go through tight bends, and yeah. So hopefully this cable holds up, but yeah, it's kind of my lifeline in a way. So this polycarbonate is very staticky, and I just had a few static discharges on the PCB of this Dishy. I wasn't even touching the PCB, but it arced really far, so hopefully I didn't just fry something, but if I put this together and it doesn't work, I'll have a good idea of what went wrong. Okay, this is looking really good. I don't see a whole lot of strain on that wire there. So I have half a mind to create an alignment jig for this thing, but I just really can't be bothered. So what I'm doing is I'm practicing how I'm going to put this on here, imagining that this is all covered with sealant. So plugging it in is going to be pretty easy. And then, yeah, I'm just going to have to plop it on there basically. And I bet I'll have enough flexibility that I can kind of tweak it a little bit. And yeah, that should be good. All right, so we're getting ready for the scary part where we glue this thing together. I'm going to clean up the edge with acetone, and then I'm going to put a glob of sealant on this wire, glob sealant on my breather, flip it, do another glob, and then we'll do the perimeter and stick the dish on. All right, this stuff seems super gooey. It's kind of scary. Zip tie this down so we're not pulling at this wire while this is curing. Now we're gonna flip. And do a nice thick and hopefully even bead. And now, just like we practiced, we're gonna set this on here. Alright, that looks pretty good. I am going to put a little bit of weight on this, but I don't feel like it needs a whole lot. So I just have a box of sandpaper. This weighs maybe 15 pounds. Alright, I maybe went a little hog wild with the sealant on that side, but less isn't always more. And yeah, it's kind of cool. We can look underneath and verify that this is looking good. And it's nice to have a little sample set aside, squirted out the same time that you squirted out this stuff, so you can check the tackiness without ruining your beautiful bead here. Okay, so it has been 40 hours. Unfortunately, I don't think this is fully cured yet. It's been ridiculously dry in Colorado. The relative humidity was as low as 20% yesterday, so looking at my test piece here, it's still pretty gummy. But the smaller bead on this side feels pretty hard, and this is on here. A lot of people will put straps and other brackets on top, but I'm not worried about it. I'm not worried about washboard or anything. I think we got a really good bond here, so now that I'm looking at it, I'm not so sure. Okay, so this is really interesting. It almost looks like in the lighter areas, the sealant has pulled away from the polycarbonate. And I'm really not sure why it looks like that. The good news is that we have a gray sealing line, although it gets really thin through here. And then it's also really thin through here. But that is going all the way through, and if I had seen this, I wouldn't have been shaking the dish upside down, but I still think we have a really solid seal here, so I'm gonna just go ahead and go with it. I don't really see this failing anytime soon. Unfortunately, this frame accentuates how crooked the Dishy is in here and unevenly spaced, but from afar it doesn't look too bad. And this is 1 inch 80/20, so we are sitting about exactly 1 inch tall here. And what's nice about this is there's no opportunity for wind to get underneath here. So it really just needs to stay on there mechanically. It's not going to get blown off, and washboard is going to be our biggest enemy. Okay, so I got a switch wired up to my router. Router's hanging out up here. And we got our breather hose in here. And all I gotta do now is plug this in. Okay, so now we turn it on. I'm just gonna turn it on and walk away and give everything time to get up to speed and connect. And hopefully when I come back out here, we will have Wi-Fi. Okay, the router is up. I'm connected to the Wi-Fi. Just gonna do a speed test. Man, my heart is pounding, but the web page loaded, and here we go. It works. I used a dull drill bit to widen out these holes and crack the polycarbonate. Thankfully, the cracking hasn't propagated through to the dish yet, but it might at some point. So let's hope that doesn't happen, because I don't know what I would do if that does happen. All the other holes are not cracked, so it's definitely a result of me using a dull drill bit, but also be careful not to tighten these too much. All right, so we got that all siliconed up. And the solar panel wires back up over here. Can't really tell what's going on up there unless you really know what you're looking at. And then, yeah, there's my switch to turn the Starlink on. And then that's where all the electronics live, all tucked away.